Let's take a look at some complex numbers. Consider the equation x squared plus 1 equals 0. That's a pretty simple looking equation in a way, but leads to something very interesting. This is the same as x squared equals negative 1, just subtracting 1 on both sides. And what we see is that that equation has no real answer. Some people will tell me the answer is negative 1, but if I take negative 1 and square it, that's negative 1 times negative 1, that's positive 1. Doesn't turn out to be negative 1. So this equation has no real answer. Well, what do you do when there's no real answer? You make up an imaginary one. And so we define the square root of negative 1 to be I. And we call this the imaginary number. And then a complex number is any number that can be written in the form a plus bi, where a and b are real numbers. A is called the real part, and bi is called the complex part, or imaginary part. So for example, 2 plus 3i, where a would be the number 2, b would be the number 3. There's a complex number. These a and b's can be fractions or decimals or anything else, so you could have 1/2 plus 2/3 I. 6i. 6i doesn't quite look like a complex number, but it is, because it can be written as 0 plus 6i. So a, the real part, would be 0, and the imaginary part would be 6i. And you can do the same thing with the number 8. The number 8 is a real number, which is more important, but it turns out that the number 8 is also a complex number, because you could write it as 8 plus 0i. So all numbers that you can think of turn out to be complex numbers. Okay, write each of the following as complex numbers. Well, here's the basic idea. This I thing is going to allow us to get rid of negatives under square roots. So we're going to write this as the square root of 25 times negative 1, which is square root of 25 times square root of negative 1. Square root of 25, of course, is a nice number that you know, that's 5. And the square root of negative 1, that's I. So basically what's going to happen, we wouldn't normally put all these intermediary steps in. When you have a negative under a square root, you're going to square root the number as normal. Square root of 25 is 5, and the negative causes an I to happen. So 4 plus square root of negative 9, that would be 4 plus square root of 9 is 3, and because there's a negative under the square root, we get an I. And that's really all there is to that. Square root of negative 27, well, we would write negative 27 as 9 times negative 3. The square root of 9 is a nice number, that's 3. And then we have square root of negative 3 left over. There's not a lot I can do with that, but I would write it as 3i square root of 3, because I have a negative underneath my square root, I get an I, and then the square root of 3 is not a nice number, so I just leave it as square root of 3. Alright, adding and subtracting complex numbers. First thing you want to do is write these in the form using the I notation. So this would be 3 plus 4i plus 5 minus 6i. And then you simply combine like terms. 3 and 5, those are both real, so those add up to 8. 4i minus 6i, those are the imaginary parts. They're like terms, you add them. You get 8 minus 2i. Alright, subtracting really isn't any different. What I would strongly suggest you do here, though, is take 1 second like that to distribute that minus sign through. And this is just a simple thing. When people try to do this all in once without distributing that minus sign through, they almost always lose a negative sign somewhere and make a mistake. So I strongly recommend you take the time to do that. 4 minus 5 is negative 1. Negative I plus 6i is 5i. One more step involved here. You've got to distribute first. So this is 30 plus 33i minus 100 minus 30i. And we use that and we say that's 30 minus 100, that's negative 70. 33i minus 30i is 3i. Multiplying complex numbers. Multiplying complex numbers, again, is not a difficult thing. The key to multiplying complex numbers is to remember that I squared is negative 1, and that's because, remember, we said I is the square root of negative 1. So if I were to square both sides of this, I would have I squared equals negative 1. And we're going to use that. So let's see what we have here. We multiply just like we normally would if those were x's. If those were x's, we would distribute, do FOIL if you prefer, and combine our like terms. We're really going to do the same thing here. We're going to have 8 minus 16i plus 12i minus 24i squared. And then we combine our like terms. So we have 8 minus 4i, but then look at this one. This one has an I squared. I squared is the same as negative 1. So this is negative 24 times negative 1. That's plus 24. Final answer, 32 minus 4i. So it's multiplying just like we've always done. The only difference is when you see an I squared, you turn it into a negative 1. Combine your like terms. All right, this one, before I multiply, I would write this as 3 plus 3i times 7 minus 2i. Clean up those square roots, and then go ahead and multiply. 21 minus 6i plus 21i minus 6i squared. So that's going to be 21 plus 15i plus 6. Again, I'm using the fact that I squared is negative 1. A negative and a negative makes a positive. Final answer, 27 plus 15i. All right, and then number 3. Notice what we have in number 3. We have a name for this. We used this word before. These are called conjugates. Conjugates happen when you have almost the exact same thing, except one has a plus and one has a minus. And what we saw when we multiplied conjugates is that the middle two terms added up to 0. And that's still going to happen. I'm going to multiply the whole thing out, even though I really don't need to, just to show you. So 5 times 5 would be 25. And then we would have minus 10i plus 10i and minus 4i squared. And notice what I said. Those middle two terms add up to 0. And that always happens when you multiply two conjugates. This becomes 25 plus 4, because I squared is negative 1. That's 29. Alright, so the idea behind conjugates is the method that we use to divide complex numbers. So to divide complex numbers, you actually do kind of a weird thing. You really multiply. What we're going to do is we're going to multiply top and bottom by the conjugate of whatever we have on bottom. We're going to multiply top and bottom by 5 minus 2i. And the reason we do that is, using what we did in number 3, it gets rid of the imaginary parts down on bottom. And if you go back and look, this is really the same process we used for rationalizing fractions, which makes sense because this I is really a square root. And when we had 5 plus square root of something, we multiplied by the conjugate. Alright, up on top, I've got to do the work here. That's 15 minus 6i plus 5i minus 2i squared. That's going to be, I'm going to start skipping some steps here. This is going to be a plus 2. So 15 plus 2 is 17 minus I over 29. And then typically, this would be written this way. 17 over 29 minus 1 over 29i. And the reason we write it that way is we want it to look like a plus bi. So a would be 17 over 29, b would be negative 1 over 29. Now, personally, I'm not going to make a big deal of it if you leave your answer like that, be perfectly fine with me. All right, we have one more division to go, and then we're going to talk about some exponents. 7 minus 2i times 4 plus 5i. To divide, you multiply by the conjugate of the bottom. I always like to do the bottom first because it's the easier one. On the bottom, I'm going to have 4 times 4, that's 16. The middle two terms are going to add up to 0. 5i minus 5i is minus 25i squared. So we have 16 plus 25, that's 41. Our bottom's going to be 41. And now we've got to do the work on the top. That's 28 minus 35i minus 8i plus 10i squared. Now notice this time this I squared is going to be a negative 1. So this is going to be 28 minus 10. That's 18. And minus 35 minus 35i minus 8i is minus 43i. And again, I'm fine with you leaving it just like that. However, the computer system may force you to write it this way. So watch out for that. All right, now let's talk about powers of I. I to the 0, that's 1. Anything to the 0 power except the number 0 is 1. I to the 1, now that's just a fancy way of saying I. I squared is negative 1. We've already talked about that and used it quite a bit. What about I cubed? Well, I cubed is I squared times I, because I can add my powers. 2 plus 1 is 3. I squared is negative 1, so that becomes negative I. I to the 4th. I could write I to the 4th as I squared times I squared. Again, I add my exponents. 2 plus 2 is 4. I squared is negative 1, so that's negative 1 times negative 1, which is 1. I to the 5th. I to the 5th is I to the 4th times I. But I to the 4th we just showed was 1, so that's an I. So hopefully by now you're recognizing what's happening. Look what happened. We went 1, I, negative 1, negative I. 1, I. You should be willing to bet that the next one is negative 1. And it is, because this is I to the 4th times I squared. I to the 4th is 1. I squared is negative 1, so that's negative 1. And so if I were to continue, I to the 7th would be negative I. So here's what happens. I to a power, you get one of 4 answers. So what if I asked you to do I to the 54th? Well, you're thinking you're crazy. I'm not going to keep writing this down over and over and over again. The truth is you don't. What you do is you take 54 and you divide it by 4. And I'm just going to do the old long division here. Put a 1 there. That's 4. That's 14. 3, 12, 2. What this tells me is if I were to keep doing this list and go all the way down to I to the 54, there's 4 things in the pattern, so I would cycle through the pattern 13 times, and then I would have to go 2 more spots. In other words, I to the 54 is I squared. You divide by 4, and it's always whatever the remainder turns out to be. And I squared is negative 1. I didn't leave spacing very well here. I'll do this down here. I to the 1967, you take 1967 and you divide it by 4. That's going to be 4, 16, 36. 9 is 36. Bring down to 7. 1. Remainder 3. And you can divide by your calculator. The key is, though, you need to recognize what your remainder is, because your calculator doesn't give you remainders. So if you can figure that out, that's great. Otherwise, divide by hand using long division. Anyway, this is the same as I cubed, and I cubed is negative I. So for 1967, we cycle through the pattern 491 times and get to R cubed. I cubed, I meant.